Okay, today we're going to talk about discrete versus continuous. Really, discrete functions differ than continuous functions by whether or not you connect the dots or not. A discrete function, you will not connect the dots, but under a continuous function or continuous graph, you will connect the dots, and even if they're dots on the line, they are connected. That is a continuous graph. So let's take a look at two different graphs. Here's a graph of a sequence. Remember, a sequence can only have inputs as whole numbers, so 1, 2, 3, and etc. So when we plot those, the inputs and the outputs for a sequence, notice we will not connect the dots because there is no 1.5 term or the 1.35 term. We would never plug that in for n. Under a function, however, we can have inputs of 1.5, 2.7, things like that. That is continuous. Now, sequences aren't the only things that are discreteness or has discreteness. Look at this example. Simon sells candles for money. For each candle that he sells, the school will get $2.50. He has a total of 10 candles that he can sell. Well, the input for this is the number of candles. And the output for this is money. Now, what you need to do in order to determine whether or not it is discrete or continuous is ask the question of the candles. Can I sell like a half a candle? Well, no. I mean, you wouldn't do that. So that's discrete. But you also need to ask that of the output as well. And in this case, the output is money. But money, you do have $1.50, you do have $1.75, and etc. So that is a continuous function, although we don't go out to 3 decimal places. We still consider it to be continuous. This, though, because the number of candles is discrete, makes the function discrete. This is a linear function, because for each candle I sell, I will add $2.50. So my function notation would be f of x is equal to that $2.50 per candle. That's what changes each time. And we have a starting value of 0. So you could do plus 0 if you need to. Now to graph it. If I sold 0 candles, it would be $0. If I sold 1, it would be $2.50. If I sold 2, that would be $5. Up to a total of 10 candles. If I sold 10 candles, the total amount of money I would give would be $25. Do we connect the dots? No, we don't connect the dots because, again, this is discrete. Jamie is taking a typing class. At the end of the week, he improves his typing speed by 10%. His current typing speed, or he currently types at a rate of 25 words per minute. The input for this is number of weeks. And the output for this is typing speed. This is a continuous function because number of weeks, we can have half a week, we can have a third of a week, we can have all of that. And typing speed, you can type at 25 words per minute, you can type at 26.5 words per minute, so there's no problem there either. That can be an input, that can be an output. This is exponential. Now, in the problem, what tells me it's exponential is that 10%. Because that's your rate, then I need you to recall what we did first semester. Y is equal to A, the starting amount, plus 1 plus a rate raised to the x power. So function notation for this would be f of x is equal to my starting amount, which is 25 words per minute, times 1 plus 0.10 raised to the x. Sketching it, not to scale, let's say that this was at 25, that's my starting amount is 25. And since it's continuous and exponential and it increases, then you should see a growth like that. A puppy is gaining weight at a steady rate of 3 pounds per month, and the starting weight is 5 pounds. The input for this is pounds per month, so months, the number of months. The output for this would be weight, or pounds. Number of months is continuous because I can have half a month, a quarter of a month, all of that. And weight is also continuous because you can weigh 3.5 pounds, 5.5 pounds, and etc. Since both are continuous, the function is continuous. This is also linear because we're gaining 3 pounds per month for each puppy. So my function notation will be f of x is equal to what my starting amount is, which is 5 pounds, and then each month I'm gaining 3 pounds per month. To graph this one, I would start at 5. Let's say each of these are by 5. So we'll start there. And then up 3 and over 1. Since it is continuous, we would connect the dots. Ivy is selling ice cream, and each ice cream costs $1.50 if she has 6 of them to sell. So first I would say the input for this is number of ice cream. Okay, can I sell half of an ice cream cone? I hope not. So that would be discrete. Okay, it is linear because I'm adding $1.50 each time. So my function notation will be f of x is equal to $1.50 per ice cream that I sell, and I start with $0 if I sell none. Okay, so 0, and then $1.50, and then $3, then $4.50, then $5. $6, then $7.50, and then $9. And that's it, because I can only sell a total of 6. Now the question is, do I connect the dots or not? Because it is discrete, the answer is no, do not connect the dots. Input and output. If Sharon is trying to adopt these animals and she has 9 of them and each day she's able to get one adopted, then should I connect the dots here or not? The answer is no, I shouldn't. Although time is continuous, okay, time a day, half a day, quarter of a day, and all of that, the fact that we're selling animals or adopting animals out is not. You can't adopt half of an animal, okay? So this is discrete. It is also, by the virtue of what the picture looks like, it is linear. As far as function notation, f of x is equal to, we started with 9 puppies and we lose 1 each day. You can always check it by plugging in a 1, a 0, and etc. I'm riding my bike. Should I connect the dots on this one? Okay, time of day is continuous and distance is continuous. So the answer is yes, I should, because this is a continuous function, linear. I would connect the dots. But now graphing it is a little different. I mean, not graphing it, writing the equation is a little different. See, the function notation for this one would be, I start at 0, but look at the slope. Watch your scale, because the slope says up 1 and over 10. Up 1 and over 10. So 1 over 10x. So discrete versus continuous. The bottom line on that is to ask the simple question of, can I sell half of that? Can I, is it okay to have half of whatever the input is or whatever the output is? If the answer to that is yes, then it is continuous. If the answer to that is no, then it will be discrete.